Well, gentlemen, what he basically brought out the aspect of MANET as well as the static networks, while it was so simple, or rather I would say it was easier for the static networks to handle. But the Army, or for the matter defense forces, especially the Army, I would say, is not going to work in a static environment. Here comes the requirement of mobility. And I think the challenges that he mentioned about, whether it was radio or router or switches based, is a unique in its dimensions, and the solutions are not easy. When it comes to the multiple deployment scenarios, as he mentioned, well, the project BMS, I think, is on the anvil, which will throw not only the challenges to the industry and everybody. I think the real challenge lies in finding the solutions for our multiple platforms to use the same in different shape and size. So let's look at the solutions for our upcoming project. Once again, thank you very much. I'll come to the next panelist, Mr. Jayesh Shah, the Senior Principal Engineer with DRS Tactical Solutions. An electrical engineer by education, he's done it from the University of Mumbai. Master of Electronics Engineers, Electrical Engineers from Stevens Technology, USA. He has been Systems Engineer by current professional responsibilities, has worked in various engineering capacities in communications, mostly SATCOM and defense electronics. He has been involved with the US Army's key program for the last 7 years plus. In that time, he has seen the growth of program to over 175,000 systems with transitions to latest technologies in rugged computers, displays, networking, and handheld systems. He'll talk about various DRS solutions for enhancing the integration of BMS program, its technologies into space constrained and operationally challenged commander's vehicle. Over to Mr. Shah.
Sunit Kumar, distinguished panelists, ladies and gentlemen, as General Sunit Kumar said, I'm Jay Shah from DRS Tactical Systems. I'm taking place of another gentleman who was scheduled to speak here earlier, but he could not travel due to some reasons. Anyway, we're going to talk about the challenges faced when it comes to integration of technologies needed for battle command, battle management into a commander's vehicle. As you will recall, General K.J. Singh said this morning about how space constrained the tactical vehicles are, how space constrained the tanks are. They are evolving from their mechanical stage into the next generation of electronics platform. They were originally not designed to integrate this level of electronics. They were designed, as General Singh said, for mechanical purposes. So the challenges are there to find space. The challenges are there to find power to operate all these various electronic systems you're going to put in there. The challenges are there to mount antenna so that they don't interfere with the turret moving 360 degrees. So there are a number of challenges that are there, and we're going to talk about some of that. Just a brief overview. DRS Tactical Systems located in USA. For the last 30 years or so, we have been involved in defense electronics. Mostly in manufacturing rugged computers, displays, networking systems, handhelds, number of things. Information on our facilities. We are a fully integrated development house, if you will. We do everything in-house. All our engineering capabilities are maintained in-house, and one of the prime reasons is so that we can closely meet the customers, the users' requirement in coming up with solutions that are going to solve his problem and not just our need to sell boxes. We have very qualified mill standard labs. As you will see, the challenges of integrating these systems into tanks or any movable platforms are quite high. So what gives us this right to talk about this? DRS Tactical System has been involved with the U.S. Army's FBCB-2 program for over 12 years. FBCB-2 is the BMS program for the United States Army. And even after 12 years, that program continues to evolve. It started on a smaller scale, then the troubles and the wars in the Middle East helped it along, and the program has now grown from a few hundred systems initially to over 175,000 systems, and DRS has provided the rugged hardware for every one of those systems. We're also involved in a number of different programs in India, the U.S. Army, the U.S. Marines, the U.S. Air Force, and last but not the least, we have also been selected to supply the rugged tactical computer for the Indian Army's battlefield surveillance system, the BSS program, for which we have already supplied over 225 rugged tactical computer systems to Bharat Electronics in Ghaziabad. We make rugged computers and display systems, network and communications gateways. We make dismounted warfighter system that allows the commander and the soldiers to dismount from their platform, be able to move away from the platform and still be able to maintain the situational awareness through either handheld devices or pocket devices, smartphone type of devices. We integrate all this with our own Mission Command software suite, which ties all these capabilities together in a very intuitive user applications that executes on our platforms in a distributed fashion. Our sister companies are involved in making systems that create operational power on moving platforms, smart power management, platform test and diagnostics. We have talked enough about the objectives of the BMS, so I'm not going to read what the BMS is supposed to do. But in order to achieve these objectives, you're looking at a number of different systems that need to go in a platform. You need something that collects sensor data, something that provides wireless communication, weapons control, vehicle test and diagnostic electronics. You need commander's console where he can monitor all these. And you also need to generate operational power. So when you start looking at this, you need all of these integrated so that the right information is provided to the right person, the commander, at the right time, so he can make the right decision. That is the purpose of this system. Let me quote a few things from some of the noted military leadership in Indian Army. Lieutenant General Kochar, signal officer in charge, in his interview with SP's land forces in May and April 2012, said at any given time, any large army like ours will have a certain percentage of equipment of legacy and vintage technology, and we must ensure the continuity of the operational life and coexistence of these legacy systems with the modern systems. So the key there is, when you go to BMS or any battlefield digitization system, you are not automatically overnight or over a smaller period of time going to just completely transform technology from one to the other. You need to coexist. You need to coexist with your legacy voice radio. I think they're called Star 5 radio. You need to coexist with other electronic systems that are in the platform currently, and slowly transition to the newer technology without losing functionality or the operational capabilities of the platform. Lieutenant General Vinod Nayanar, DG Artillery, in the same issue of SP Land Forces, said, while ACCCS has been a landmark achievement for artillery, its fielding has brought forth many equipment challenges. Any battlefield digitization program will bring integration challenges. It is not just a matter of specifying individual boxes, bringing it somewhere, and expect them all to work. It just doesn't work. After 12 years of FBCB2, we still find those challenges today. Again, the challenges are due to the type of equipment, the incompatibility with equipment from different vendors. You have interface incompatibility, interoperability, finger pointing when one thing doesn't work, and the blame's passed on to the other. One more quote from General Kochar. He said the Indian Army is looking at a number of different wireless technology, WiMAX, LTE, cellular, software-defined radio, combat net radios, system command on the move, and of course you always have the legacy voice or the next generation of voice, but you are going to have PTT voice radio. So the challenge is not in purchasing this technology. You can get these technologies today, but challenging is to integrate these technology in a space-constrained commander's vehicle. So the immediate question come to mind is, where am I going to put all this stuff in my vehicles? I don't have any space. How much weight is it going to add to my vehicle? My vehicle's already heavy. Where am I going to get the power to operate all these systems? How much does it cost? Is it rugged enough for combat condition? These systems are integrated, they're interdependent on each other. Failure of one can cause the failure of entire system. A unit, simple thing failing in a system will bring your commander's vehicle down to its knee, become inoperable. So, what does a mission-capable battle management on-the-move system need? You need a number of different things. You need to consolidate all these different technologies of communication, sensors, radios. So you need something that allows you to cross-band between voice and data circuits. You need Wi-Fi interface, you need IP routers and switches, as Mr. Shoki said. You need radio management, tactical servers, storage, platform GPS distribution. Every single piece of electronic, defense electronic that goes into a platform needs GPS feed. Regardless of what it is, it's going to need GPS feed. Does that mean you're going to put 8 or 10 different GPS antennas on your system and feed individual GPS to each of those systems? Because these systems are not designed to share information. So you need something that takes a single GPS feed, feeds it into a platform distribution system. And on top of everything, you need intuitive user interface that allows a commander or his junior officer to operate this system without flipping a manual every 10 seconds to read instructions. It should be intuitive. He should be able to just push the text button, the touch screen, and be able to operate this system. DRS is in that business. The 8 or 10 boxes we see here, we have replaced the entire requirements of those 2 boxes with these 2 systems that you're looking at here. One on the left is called the DDU, is our data distribution unit, and the one on the right called MRT is our military rugged tablet, which is the same tablet computer we have provided to the BSS program. I will talk a little bit more about the DDU, the data distribution unit. And we have something called a mission command software suite, which allows the combination of the DDU and MRT to provide all the capabilities that you saw previously on the slide. So at a practical level, a combination of a DDU and MRT operating with a mission command software suite allows you to replace And I'm not taking anything away from Cisco. We work closely with Cisco in coming up with this solution. It allows you to replace an individual rugged Ethernet switch or rugged IP switch, IP routers, or video distribution unit. We have talked about the need for sensors. Video sensors are very critical to the operation of a command vehicle. It allows you to replace multiple GPS modules. It allows you to replace a separate cross-bending system and, of course, a tactical computer. So what is the DDU? The DDU is a powerful tactical server, if you will. It is based on, DDU and MRT are both based on the latest generation Core i7 Intel CPU with large amount of RAM, large amount of solid-state hard disk drives, and a rich, very rich interface environment that allows you to interface with many different sensors, many different communication equipment, many different weapon systems, etc. They weigh very less. The box, as you see, is about twice the height of a typical laptop, if you will. The MRT tablet is about the same. Twice the height of a typical laptop with the same dimension as a footprint. The Mission Command software suite we provide consists of many different applications. I have listed only a few here. The C4 Manager ties everything together. It allows you to manage all these multiple applications. If you will notice on the MRT, you see multiple screens. Actually, what that is showing is video input from 4 different sensors on the platform on the same screen. The smaller screens on the bottom don't do justice to what I'm talking about here. But the C4 Manager ties all these different sensor input, the radio control, weapons management, all into one place, so you don't have to run multiple applications yourself. The Voice Call Manager allows you to route calls from your voice radio to your data radio to your SATCOM system all the way back to the command center. So theoretically it is possible, and we have proven it during a lot of tests, is that a soldier with a PTT radio out in the edge of the cloud is going to be able to talk to somebody all the way back at the command center with the proper settings and routing of the system. The NetOps Constable and the network planner, all these things require network planning at the vehicle level, at the battalion level, at the company level, and so on and so forth in the hierarchy. The need is for rugged systems. Now we have heard the fog of war. There is a fog of specifications out there in the industry about what is rugged. And people like to call a lot of things rugged. Rugged does not mean that you find a cheapest circuit board somewhere and put it into the heaviest aluminum or a steel box possible that makes it look like a tank, put circular connectors on it and call it rugged. No, sir, that does not mean that. The rugged starts all the way from inside as to how you select your integrated ICs on the board, how you select those placement of the components on the board, how you make the printed circuit board, how you interface it with the rest of the system. Because rugged does not just mean that if you drop it from a 3-foot height and it doesn't break, then it's rugged. No. Those of you, I'm a civilian. I have been in a tank only in just observer capacity in a very controlled environment. But those of you who have worked in the tank would know the tank is one of the most vibration-prone environment. And one of the things, Colonel Mosher, if you will remember, he likes to say that if you're riding in a tank, your teeth are going to come loose eventually because the vibration will just keep clicking your teeth. And when you...
to finish off.
Okay, I'll be very quickly, sir. And the gunfire shock, when you fire the shock, if it's able to move your whole tank, it's going to hurt your system if it's not done properly. So rigorous testing, rigorous compliance to those standards is very critical. That's what makes a rugged system rugged. And we have been doing that for the last 30 years now. So we know one or two things about that. The next few pictures are allowing us to see various capabilities of platform integration just through those two boxes in our software system. You can integrate the mission command capability with crew station, displays, commander station, battle command applications with only those two. In the next slide, the same system installed in a vehicle also allows you the communications management capability. You don't need another set of communications management hardware. The same system that's running there with different application will also allow you to do control soldier radios, control cellular interface with a local cellular infrastructure when you are in an urban environment. You have beyond line of sight SATCOM system, and you also have the line of sight and beyond line of sight terrestrial system that allows you to communicate from one commander's vehicle to the other commander's vehicle. Integrated sensor control. You have driver vision enhancement, which is the infrared-based driver vision aid that allows him to drive in night and fog. You have UAV, video and data feed, weapon system, 360-degree SA cameras mounted on top of the vehicle, and the built-in vehicle diagnostic when things fail in the field. And integrated platform electronics, smart power management. Power generation becomes very important. Your electrical system for the vehicle was designed to power its own requirement. It was not designed with spare capacity. When you start adding all this equipment, you start adding radios, you start adding SATCOM systems, suddenly you need 10, 20, 30 kilowatt systems additional. You don't have the power. So you must generate power when you are moving. So we have something called onboard vehicle power generators, OBVP, vehicle health management system. Every time there is a network, you must have built-in diagnostics in the system that allows the system to diagnose itself, allows faults to be found. As General K.J. Singh said this morning, your soldier comes from a village. He's not a scientist. He's not a network engineer. He's not a software engineer. He should be able to depend on the system to tell him what is going on, what needs to be done. Our contact information, I'm Jayesh Shah, and Mr. Ted Devlin is our Director of International Business Development. He is here with me. Please feel free to contact us if we can help with any additional details. My thank you to respected guests, respected panelists, General Sunit Kumar, Claus, and my friend Jayant Baranwal at SP's Guide Publication. Thank you very much.
Thank you very much, Shah. Well, gentlemen, you just heard a galaxy of platforms that the DRS has to offer. They're looking at the BMS program, but only thing, a word of caution, as General K.J. Singh probably mentioned in the morning session today, that all this technology and the platform that you are having in the inventory for the US Army or the Western armies, you have to all make sure that it is used or it is usable by the same soldier who comes from the village. And therefore, before the AVM Tiwari starts, he has covered the subject on the security. If anybody has a pressing question,
send an email.
You can send the email. Okay, sir, Jaldeva sir, but keep it to only one question. A very brief, sir, very brief question. He has only 2 minutes to answer, sir. No preamble, please.
Could be clarified especially by Devinder Kumar. The difference between the terms cyber, digital and information space, cyberspace and battlefield, connected with warfare. And the second one is whether brain is digital or it is analog. Thank you.
Well, sir, Jalpant can leave. Sir, D. Kumar is here only with us. He'll answer all your queries later on. I think we'll allow Jalpant to leave. Thank you very much. Thank you very much, sir.
Just take care.
Sorry, sir.
Okay, coming retired, he is an alumnus of National Defence Academy and Defence Services Staff College. Has been an eminent fighter, pilot of the Indian Air Force with over 20 years of flying experience. During his service career, he excelled in professional courses and field and held distinguished posts at various levels in Air Force. He did the Air Warfare and National Defence College courses. He did the Air War course from US Air Force Air University. He has been a keen proponent of air power and has authored several books and articles in prominent periodicals related to the subject. A.V.M. Tiwari held the Maharaja Chhatrapati Shivaji Rao Chair in 2002-2003 and the USI Research Chair in 2004 and 5. I request A.V.M. Tiwari to kindly speak now.
Respected Chair, ladies and gentlemen, the opportunities if you use the technology in an integrated manner. Even then, when the US started experimenting, their loss rates in UAVs were 30 times the manned aircraft. Slowly they are bringing it down by learning how to integrate. So the choice is not there whether to integrate or not. Choice is only how well to integrate. And the threat is, if you don't integrate, the technology becomes not a boom, but a bane. I have focused my presentation from the user's point of view, basically planners and operational, and from the industry point of view, where the opportunities are for them to think what the services would need and work on it. Since so many eminent speakers have already given so much information and covered most of the ground, I will run through some of my slides. They don't need any explanation, unless of course you want later on. 90s vertical line is only because of integrated operations. Thanks to Raytheon, I have borrowed 2 or 3 slides of their presentation from the internet to make my task easier. So the UAVs were there earlier. It's a real-time integration with everyone. And that's why everyone talks of UAVs and UCAVs, because spectacular results keep coming. This also you are familiar of various reasons why the kill chain has shortened and why the armed UAVs leading to UCAVs, which are yet to be incorporated into the services, are required. Just very brief how it is connected when you are using a UAV. It's never in a standalone mode really. Satellite queuing the targets to the higher one, Global Hawk, which might queue in turn to Predator, which will search the target, find the information and pass in real time the video to the AC-130 gunship, which will go and engage it. And the same thing will be relayed back to the command center for battle damage assessment and further action. There's another target development process using the electronic warfare aircraft, which pick up the signals, various signals transmitting, and passes the information to Air Operations Center, which is combined, which will use all the assets, JSTARS, AWACS, P3, to direct the available UAVs to go and search for the target and again pass on to either Apache or the AC-130 or to the fighter, whichever the strike element available, or even for that matter to the ground missiles or cruise missiles. In US, this is the global information grid, which connects their battle space, not the battlefield, the battle space, the entire global space. everyone is feeding into this global information grid. This is a diagram of the 90s. Only point I want to emphasize in this diagram is about 3 to 4 megabits is the communication requirement for each link. And there are various links going from one to another. And similarly, in the video link, for your information, Predator requires about 6 megabits and Global Hawk requires 500 megabits of bandwidth. This is an explanation of how the UAV is being used in real time. It's flying over the battlefield. It has picked up a target. Now that picture is being passed to all the centers which are listed there. There is Central Command at Nellis Air Force Base, Command and Control Center at Nellis, CENTCOM at Florida, CENTCOM Advanced Headquarters at Qatar, Pentagon, CIA, CAOC, and to the command headquarters in the battlefield itself. The important point to see is on the right side, top side, that the various operators from all these headquarters are chatting in real time on the net or the intranet developed by the US Armed Forces for themselves to derive the actionable intelligence to get the target. So there is the kind of integration if you want those spectacular results. This is how the ISR used to work in the past. Sensor to shooter cycle was almost 2 days to 7-8 days. And mind you, Kargil was not much different from this. This is one of the pictures of one of the Combined Air Operations Center in Saudi, manned by the US forces. The manning level initially was 750. 750 people were trying to coordinate in real time. And with automation, they are bringing down the number of people. Okay, so in simplified block diagram, in an air operations center, you have various cells of air defense, strike, target support, close air support, and one of the cells is ISR cell. In this ISR cell, for it to function properly, this is the kind of data which needs to come from various agencies. Just a second. The software, algorithms, which we have not talked much. We've been talking of the connectivity. That also is a very important part, 50% part I would say, is leading to data fusion. From that data, your intelligence analysts are processing the information, getting the intelligence which is actionable, passing it to the strike aircraft, and then the execution is taking place. If you want this in minutes, or even in an hour, you can imagine the type of other air traffic controls, etc. And then the links like CPDLC, automatic data surveillance, flight information systems, etc. will come. Why I'm talking of these? Because I'll tell you the weakness of these links which are there, which need to be addressed. Everyone knows bandwidth requirement is increasing. The important thing to remember is that circuit design and putting it on the ground takes months. So you cannot ask the engineers to do this overnight. It is not possible. Our planning must cater for this long lead time. And media also, depending upon the quantity which is available to you, will always be short of it. Nobody has been having sufficient quantity. You have to decide how much is secure and how much can be unsecure. The lesser security, lesser is the requirement of the bandwidth. The system being followed in the Western world is they have divided the data into broadcast control and pull data. That means certain amount of intelligence data, which is like sit reps or monthly or weekly or daily summaries of intelligence, are broadcast by the various headquarters, and users receive it probably on a commercial link, and unimportant information is even unsecured, which doesn't require much of bandwidth. The secure, because of encryption and decryption, will require more and more bandwidth. Then the next question you have to decide is who all require the video, and is video required every time, or is still image will do? It's nice to have a video, but is it a requirement? Because once again, your demands on the communication bandwidth are increasing quite a lot. Until yesterday, we were only working on stills, still photographs, still images. So why should everything be on video? Next question we must address is it real-time requirement or is it periodic requirement? If everything is real-time, that means, on your own television, you cannot pay all the channels that are available to you. You can only select a channel at a time or maybe 2 channels at a time. So this will also decide the communication requirement. Levels of access control. Once you have cataloged the target data, etc., which is being updated, the access control has to be decided. Otherwise, if everyone starts pulling every information, then the security breach, and therefore the need for security increases. Addressing categorization into must, should, could, prioritization for dissemination. Just to give you an example, when you get a photograph, say from a photographic aircraft, should it go first to the commander-in-chief or should it go first to the shooter? Who needs it most? Who's got the priority? Unfortunately, we have always followed the seniority principle, that first it must go to the chief, then to the CNC, then to the station commander, and last to the shooter. With the real-time integration, it has to go to the shooter first, or maybe simultaneously. Difficult decision to make. Encryption versus non-encryption. It's easier to say that we'll import Chinese equipment and we'll encrypt and decrypt every time. This is what the statement was of the Home Minister when somebody raised a concern on Huawei products. Encryption will solve our problems. There's much more to just encryption in the routers which can go wrong. But if the world is Chinese and there is no other way to go about it, even then you have to decide how much to encrypt, who all to encrypt, and what level encryption is required. Simple or multiple or going up to 516, whatever. And the intelligence data UAV normally is giving you in the form of photographs. What is the quality that you need really? Do you always need the best? If you always need the high definition, best quality, then once again the bandwidth requirement is exponentially increasing. A few pixels less will still do your task. Actually, basically a fire control system just requires 8 figures of coordinates. It doesn't really require the target video or image in reality. Because the days of pilot or shooter acquiring the target visually and firing are over. That is a primitive stage of firing. This primitive stage of battle, it doesn't take place anymore. It's on information, it's 8-figure grid reference. So then you probably don't require the video. If you require the video, then minimize it. And the megapixel quality. It's like your digital camera, 1.3 will do. Do you still want 10 megapixels or 25 megapixels? You see the cost difference and complexity. Now, few information about the UAV communication links, which also developed like the TCP/IP protocol. Civil UAVs, these are all civil industries initiative. So there were no spectrum regulated for the UAV development. At some of the frequencies they use are 900 megahertz, 2.45 gigahertz, etc. and all. And company to company use their own. So there is no standardization. That will lead to EMI later on. Most of the information which is being transmitted, exchange is on TCP/IP protocol, IPv4, which has got tremendous security problems. These are the various types of electronic attacks which can take place on the communication links. And how to guard against it or to accept it. If you're going to use TCP/IP4 because that is the only thing which is available to you, then learn how to guard against it. I will not go into the details of that, time being a problem. So for unsecured links, use the encryption algorithm. There's no authentication. UAVs are being hijacked. Iran hijacked the Dark Star of US Air Force in December 11 and made it to land. So they have the technology. The university in Texas was asked to do a hijack test on a UAV flown by Homeland Security, and they did it for $1,000 kit. UAVs, mobile IP technology, there are problems for multicast encryption difficulties there because it has to be multicast for various users. Hands-off problem. We need to specify dedicated frequency spectrum for UAVs or work it out with the industry from wherever we are getting it. And UAV software upgrades like the computer, that can be done online, can be done on the ground. Do it only on the ground for security purposes. Firewalls is easy to say, install, shield, bound, attenuate. But remember, for each of this, you are paying a weight penalty. Or to put simply, UAVs can be categorized into 3 types of UAVs. The micro UAVs, the mini UAVs, which are with the foot soldiers, do not require any of this because they are basically one-time, on-the-spot mission and back. They really don't require much security, and they are very vulnerable being simple omnidirectional aerial. Then you have the tactical UAV, which is at brigade or division level, which has got a role in between the male class, the medium altitude class, the Predator, Huron, Searcher class, and the micro. And generally it carries only one payload. So once again, its use is more limited.
Kindly wind up, sir. Last
Yes.
2 minutes.
The main concern is the Huron type of UAVs where you need to address these security issues. Jamming, various jamming things, the counter IED jammers, cyber attacks, heavy rains, etc. Sensor problems. And now my topic said UAV oblique UCAV. The bottom left of this chart shows the problems which I was talking about, current UAVs. And when you talk of unmanned combat air vehicles which are meant to replace the fighters and strike aircraft, you have to shift to the right. Because missions increase and the complexities increases, and therefore whatever I have talked increases that much more time. Thank you very much for your patience.
Thank you very much, Vice Marshal Tiwari.